You guys, so let's start. So good afternoon, everybody. So last time I explained how can we program the 7-segment displays. We have here four 7-segment displays. So I explained the idea of time multiplexing, and you should understand why number one, you should understand what I mean by time multiplexing, what this means. This number one. Number two, you should understand why it is interesting. Okay, so what I said last time, as you see here, what you see in this figure is actually time multiplexing. So actually, if I want to display more than one digit, so as you see here, so I'm gonna turn on only one display at a time. So that's why it's called time multiplexing, because you are gonna give some time to each display. But if you do it quickly, okay, if you do quickly, you are going to set a very stable number, and that's what we saw in the video. Okay, so we need. So if you want to use more than one display, you need to do time multiplexing. So this is a task. This task you can do it. You can put it in the main program, or you can do it in the timer, in the system tech. Okay, last time I explained how can you do it in the main program. What I'm gonna do right now, also I'm gonna show you how can you put this task, time multiplexing. Someone has to do time multiplexing. Is that okay? If you want to use more than one 7-segment, someone has to do the time multiplexing. So last time I explained how can we put this task in the main program. As I made it very clear before, now, and this is the most important thing in this course, because that's what we are going to use in the future. Now your program is not going to be written in one place anymore. In your program, you have the main. Okay, so very important thing, guys. Also, we have several interrupt subroutines. Okay, so here in the main, you can put one task. Here in every subroutine, you can put other tasks. That is how we can make big applications, and that's what we did in the last lab. So in the last lab, you had 3 tasks. You put one task in the main, you put one task in the external interrupt, and you put one task in the system tech or in the timer. Okay, I'm gonna call it timer. Same thing you are gonna do tomorrow in the project. If you have multiple tasks. Okay, and you should see that all of them are running at the same time, which for sure is not true. As I explained to you before, you are going to leave the main, you go execute something, so you are going to suspend this task, you are going to go execute something and come back. You are going to suspend, but again, if you do it very quickly, you are not you are going to feel like this is multitasking. Very important, because without, if you just use the main, you cannot make big applications. Okay, so if you want to create like a big system, the system has to do many things. Okay, that is why you should we use interrupts. Okay, so what is the relation between what I explained right now and between time multiplexing? Simply because time multiplexing is a task. You can put it in the main, okay, or you can put it in the system link, as I'm going to explain right now. So last time I explained how can you do the time multiplexing. You can put it in the main. Today I'm going to explain to you, and it's almost the same thing. How can I do it in system link? Okay, so, and you should understand again what I mean by time multiplexing. And I already, from this figure or from this picture, you can understand what it means. Okay, it's like you only turn one on at a time. Okay, also, but you are going to see it like a stable number. Also, you should understand why. So why you did time multiplexing? Because last time, because of the time multiplexing, and also because if using shift register, we did something like a magic. What is the magic you did last time? The magic I did last time, instead of using 28 or maybe around 28 or maybe more than 28 pins, okay, and instead of using 28 pins to connect, this is a very naive way. If you want to connect them, you are going to need maybe more, because every one of them should be 8 pins, including the dot. You have a dot here. Okay, so it's going to be 8 times 4. Okay, maybe more than 28. Okay, anyway, let's say if you don't connect the dot, you are going to need 28. Anyway, so the magic we did last time, instead of using 28 pins from the microcontroller, because that's what you have to keep in mind. Microcontrollers usually don't have a lot of pins. Even if you have a lot of pins, still you want to maximize the use of them, because if you want to connect too many things, you got what I'm saying? But anyway, so last time I showed you, because of the time multiplexing and also because of using shift register, I'm going to use only 3. Very interesting. So I'm going to only use three pins. Okay. Anyway, so I explained this last time, and also I told you this is the time multiplexing I told you about, guys. As you see here in the time multiplexing, I want to display this number 3, 4, 5, 6 on the. I want to display this number on the 4 displays the way I did it, as you see here, guys. So I'm gonna call this function up here. If you remember this function, I told you here you have to tell me which display, and here you have to give me the number, and this function will do everything for you. Okay, I told you based on whatever written here. So this is display number 4, display number 3, display number 2, display number 1. So here, what this function is gonna do, this function is gonna display in display number 1 is gonna display this value, which is number 6. So it's gonna display 6 here. Okay, yeah, sorry, display number. It looks like it's gonna be reversed. Yeah, let me see. Yeah, no, sorry, this is display number 4. Okay, so actually you are gonna display here number 3. So number 3 is gonna come to here. Okay, and everyone else is off. So we're gonna put here 3. Everyone is off, and then here, okay, in this one, I'm gonna display number 4. So 4 will come here, and everyone else is off. Okay, and then here for this one, I'm gonna display 5 here, and everyone is off. Okay, for this one here, okay, so I'm gonna display, because you want to display digit 1 in display number 4, which is number 6. So you are gonna 6, everyone is off, and then I'm gonna repeat again, because this is a loop. I'm gonna repeat. Okay, and if you do it, you will see you have a very stable, and you have to be very cautious here, guys. Listen to me, please. In the future, if look here, I didn't put a delay here, because in this case I didn't need a delay between each one. But in the future, you may see, if you do this way without a delay, and that's what we had, by the way, last semester when I used a different processor. Okay, you will see they are dim. Why they are dim? Because you just put the voltage, remove the voltage, put the voltage quickly. So what happens, as I told you last time, for the LED, you need to keep the voltage for some time, so that the LED should reach to the maximum brightness. You got what I'm saying? I didn't need to do that here, because it's already slow, because I'm using shift register. So when I tried it, I put some delay, it was okay. When I remove the delay, it was okay. But I'm quite sure if you connected them directly without the shift register, okay, in this case, you will see they are going to be dim. So usually you need a delay here, usually, okay? And this is the trick. This is the trick, as I told you last time. After you do the time multiplexing, you can see one of 3 things, or one of the 3 things can happen. Number 1, you can see stable number, and that's what I need to do. I will be happy if I get a stable number. You can see flicker, okay, and also you can see dim. So if you find it is dim, that means you need to increase the delay here. You don't have enough delay. You don't keep the voltage for enough time. Okay, that's why it is dim. The LED does not reach to the maximum brightness. If you see flicker, as we saw in the video last time, that means you have too much delay. You have to reduce the delay. Okay, guys. So now what I'm going to explain right now, how I can do the same thing here. This is the time multiplexing. I did it in the main program. What I want to show you right now, I'm going to show you the exactly same program in chapter 4, but I'm going to do the time multiplexing using the timer. Okay. Okay. So as I told you last time, guys, or as I told you before, we have system tick, and this is a timer. And I told you this timer, we are going to use the timer if you need periodic interrupts. So if I want to do something periodic, so if your application you need to do something periodic. So in this case, you have to do you can use the timer. Okay, and this is the case. Actually, this is exactly the case, because what's going to happen is that, guys, I need to do something periodic. So what's going to happen is that in the first interrupt, I'm going to do this one. So in one interrupt, I'm going to do this one. In the second interrupt, I'm going to do this one here in this interrupt. In next interrupt, I'm going to do this one. In next interrupt, I'm going to do this one. And then I'm going to repeat again. Because I'm saying, look at the logic. So that's why I need a counter. I need a counter. Interrupt number 1, do this one. Interrupt 2, interrupt 3, interrupt 4. After 4, the counter has to go to 1 again. So that in the next interrupt, I'm going to come back again here. You got what I'm saying? This is very easy. That's exactly what I'm going to do inside the subroutine. So inside the subroutine here, every time I'm going to increment a counter, and based on the value of the counter, either I'm going to do this one, this one, this one, this one. And once I come to 4, the counter should go to 0 again, so that I can come here. Okay, very, very important. When we used here this time, the delay you have here is actually the time out. The time out. You got what I'm saying? If you make it 1 second, so what we did before, when I use the system tick, I made the delay 1 second because I wanna do flashing every 1 second. This time it has to be too short. Okay, because if you make the delay long, you are gonna see flicker. Again, guys, just to keep in mind, if you do the time multiplexing, you see flicker, it means it's not fast enough. Sorry, flicker means, yeah, it is slow. So you need to reduce the delay. Okay. So if you use the system tick and you see flicker, that means here the time out here is too long. You need to reduce it. Okay. So I'm gonna jump now from here to chapter 4 to show you how can we do the same thing here, but in the system tick. Okay, guys. By the way, already we did something like that before in flashing. So here, if you can see the first program I taught here, it was about how can you make flashing LED. Is that okay? This is the first program I taught here, and actually I taught the same program using system tick. Okay, because again, as I told you, we can do the same thing. You can put it in the main, or you can put it in one of the interrupts usually. Okay, so here I'm gonna jump now to chapter 4. To see you is exactly similar to what I explained right now here. Yeah, this is flashing also. Okay, here. So here again, I want to display a stable number, whatever the number is, as you see here. Okay, guys, whatever the number is. Okay. So what I did here, guys. Number 1, as I told you, I'm going to create a counter to count. Interrupt 1, interrupt 2, interrupt 3, interrupt 4. After 4 should come to 1 again. You know what I'm saying? So this one should be this way. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so on. In one, I'm going to display 1 digit. In 2, I'm going to display another digit, and so on. Okay. And so that's why very important thing. Maybe some of you are going to be make mistakes here, either in the project tomorrow, in your project, or in tomorrow test, and so on. You know, from C language, now we have a function main. We have another function here, handler. The handlers, or for interrupts, as you know from C language, if you define a variable here, you can only use the variable here inside main. Okay, in order to make a variable that can be used by all functions, so they have to be outside here. We call them global variables. So you need to define them. That's what I did, global variable here. Okay, so that, and again, if you define something here, this is also tricky. If you define something here inside handler, okay, every time, you know, that's exactly what happens. Every time, for example, every time it's going to lose its number, its value, because it's going to be deleted. You understand what I'm saying? So for sure, I don't want to do something like here. I need this one, and after every interrupt, I need this variable to keep its value. That's why you should not define it here. Otherwise, every time it's going to start from the same value, because it's not going to keep the old value. Okay, you know, this is how it is. If you define a variable here, once you come to the end, it's going to be deleted from memory. Okay, so anyway, so it has to be global variable, this one. Okay, anyway, and then what I did, I just did the initialization here. That's it. And now the main program is empty. Okay, because I'm not gonna do. You can put, for sure, this is just a simple program. If you want to do something else, you can put a task here. because all what I did, I moved this task from here to here. Okay, so let's see how I did time multiplexing here. As I told you, very simple. In every iteration, in every interrupt, as you see here, I'm gonna see what is the value of this counter. Okay, if it is equal to 1, so here I told you this counter should be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. So when it is 1, so in 1 interrupt, I'm gonna be here. Okay, and then I have to increment it. I'm gonna increment so that next time I will come to here. Okay, in order to display digit number 2. So in every interrupt, I'm gonna display 1 digit, and every time I'm gonna increment this one. So when you increment it, so next time I will be here. When you increment, next time you will be here, but this time has to return it to 1 again. So after 4, I'm gonna go to 1 again. You got the idea? So every interrupt, I'm gonna display only 1 digit, and the delay here is the timeout between each 2 interrupts. That is why, if you see the initialization I did here, very important thing, the initialization here was a very small number. You remember before we used a very long number, it was 2 million something. Yeah, it was a very big number, 2 million something to make 1 second. Now, I want the timeout to be too short, because if you make it 1 second, it's going to be flicker. Okay, so I made it 1,000. It was okay. You can try other numbers as long as you have a stable number. You have a stable number, no flicker, and it's not dim. Okay, so we are happy. So here I tried 1,000. It was okay. You can try something else. You can try 500. You can try bigger number, smaller number. As long as it is a stable number, should be okay. Any questions? Any question here? Very easy, right? Any questions? So I did time multiplexing. I put it in the main program, or I can put it here in the system tick. Okay. Any questions? Okay. Let's have another program here. So in this chapter, to finish this chapter, I still have 2 more programs. I'm gonna explain them to finish this chapter. Here in this program, I want to do counter from 00 until 99. So this one is gonna be counting every 1 second. You got what I'm saying? So let me show if I have the video here before I show you how it works. Yeah, look here, guys. Oh no, this is something different. This is the second program I'm gonna teach. It's still counting, but it's gonna be count every time I press the button. So now I'm gonna teach 2 programs. I'm gonna use two displays. Okay, in 1 program, it's gonna be count every 1 second, like a timer. Count every 1 second. Is that okay? It's gonna count up every 1 second. Also, I'm gonna teach another program. It's gonna count, but it's not every 1 second. It's gonna count every time you press the button. Okay, and this is a very useful program. I'm gonna tell you why it's very good. So as you see here, as you will see, the 2 programs are very close to each other. But what's gonna happen is that when you wanna update the number, okay, if I put this number in the system tick, and system tick is gonna make interrupt every 1 second, and you increment the number. So this number is going to be updated every 1 second. Is that okay? Or if you increment the number inside the external interrupt, so that means every time there is an external interrupt, you are going to increment this number. And that's actually this program here. So in this program, as you see, every time I press the button, I'm going to teach this program as well right now. So as you see here, every time I press the button here, okay, so what happens here, as you see, so I actually make 1 interrupt. Every time I press, I make 1 interrupt. When I make 1 interrupt, you increment the counter, as you see here. This is a very useful program. I'm going to tell you why it is very useful. And also here, I'm not sure. I don't think I don't have the other one, the counting one. Okay, I don't have it here, but it's almost yeah. No, this finishing. Okay, I don't think I have it. But anyway, so now I'm going to choose the 2 programs. Now they are very close to each other. It depends on when you increment the count. Are you going to increment the count by the system tick every 1 second, or I'm going to increment the count inside the external timer? Is that okay? So now I have 2 tasks. That's what you should understand. I have 2 tasks. Number 1, I need time multiplexing for sure. As long as you are going to use more than one display, you need time multiplexing. This is one test. Someone has to do the time multiplexing. Also, someone has to increment the count. Someone has to increment. So now I have two tasks. You understand what I'm saying? Two tasks. So what I'm going to do right now, guys, is that time multiplexing, I'm going to put it in the main program. So the main program is going to take care of time multiplexing. Okay? Counting, in one program, I'm going to put it in system tick every 1 second. So every 1 second, system tick is going to increment the count. Okay? In the second program, I'm going to put it in the external interrupt so that every time there is an external interrupt, you are going to increment the count. Okay, guys? So now I need two tasks. That's what I'm going to show you right now. So let's start with the first one here. So as you see here, guys, I'm gonna make a variable. I'm gonna make a global here, as you see here, guys. I'm gonna make a binary variable. It's called count. Okay, this is a binary number. This number can take values from 0 until 99. For sure, it can take more, but after 99, if you increment after 99, I'm gonna make it 0 because I want to limit it between 00 and 99. Okay, and also, as I told you before, if you have a number like something like that, you need to convert this binary number to decimal. You have to divide by 10 in order to get 2 digits. Yes, that's exactly what I'm going to do. So I have a counter here. Also, I have 2 digits. So I need to divide by 10 to get the 2 digits. Once you have the 2 digits here, time multiplexing should take care of it to display it on the LCD. Okay. So let's see how it works here, guys. So the idea is that, look here, I'm going to make interrupt every 1 second. I'm going to make interrupt every 1 second. Why? Because I want to increment the count every 1 second. So actually what you should see, 00. After 1 second, you see number 1. After 1 second, you see number 2, and so on until 99. After 99, it's going to go to 00 again. Okay. Again, guys, you have the board, you have the program, you can play. How can you play? You can just make this number shorter. If you make this number shorter, you will see the counting is very fast. Something interesting. So you can see the counting are too fast. Okay. So you can control the speed of counting, because here actually what's going to happen, as you see here, guys, I made it 1 second. So that means this interrupt subroutine, I have a subroutine. This subroutine is going to be called every 1 second. Okay. It's going to be called every 1 second. Okay. So here inside the subroutine, I'm going to increment the count. That's it. Okay. And then also I'm going to extract digit 1 and digit 2. So look what I did here. So now I have a subroutine. I am sure this subroutine is going to be executed every 1 second. The hardware will take care of the 1 second. Okay. Processor doesn't need to care about or doesn't need to do count for 1 second. The hardware will do it. So already you have a subroutine. This subroutine is going to be called every 1 second. As you see here, very simple. So in every interrupt, I'm going to increment the count. Again, I'm going to repeat it again. This count has to be global. As you see here, I have to define it here. If you define it here, if you define count here, once you exit a subroutine, it's deleted. So every time you are going to start from the same value. Very, very important. You got what I'm saying? So anything you define here is, once you come to the end, it's going to be removed from memory. So it's not going to maintain, it's not going to keep the count. So that's why it has to be global here. Okay. So as you see here, every interrupt, I'm going to increment the count. And then if count is equal to 100, I'm going to make it 0. Because I want to count from 0 to 99. After 99, I'm going to go to 0 again. Okay. Also, as you see here, as we did before, I'm going to extract by divide by 10. As you see here, I'm going to extract the first digit and the second digit. Okay, guys. So this is done every 1 second. So every 1 second, I'm going to increment the count, and then I'm going to update digit 1 and digit 2. Is that okay? And again, all of them are global. All of them are global. So because they are global, digit 1 and digit 2, the main. So digit 1 and digit 2 are going to be updated here. Time multiplexing, I'm going to put it in the main. And the main is going to use this value, 2 values here. The main is going to use 2 values. Is that okay? That's exactly what happened. So if I go to the main, here, yeah, if I go to the main, as you see here, so yeah, if I go to the main here, guys, as you see, so here I'm going to do the time multiplexing here in the main. Again, so here, every time I'm going to take digit 1 and digit 2, and digit 1 and digit 2 are going to be updated here. Every 1 second are going to be updated here. So in the very beginning, this is actually 0, 0. Okay. After some time, this is 1, 0, 1, and 0, 2, 0, 3, and so on. Okay. So here, I'm going to just take these two variables, and these two variables are going to be updated here. Any questions? Okay. One more thing. I want to add one more thing, guys, here. So actually, this program has 3 tasks. This program has 3 tasks. The first task is time multiplexing. Again, as long as you are using more than 1 7 segment, you need time multiplexing. More than 1, you need time multiplexing. So time multiplexing, I decide to put the time multiplexing here. Okay. Number 2, I need another task. I need to update count every 1 second. So every 1 second, I want to update count. So I'm gonna put this task here. The task here. I have another task, a third task. The third task is I wanna how I can stop counting and resume counting. Okay, so here I'm going to use the external pin for that. So here you will see the video right now. It is counting. Once I click this one, okay, so it's gonna stop counting. Once I press again, it's gonna count again. Okay, let me choose a video. So or before I choose a video, so here. This task should be done in the interrupt subroutine, as you see here. Okay. So what I did here, guys, in the interrupt subroutine. Yeah. So here in the interrupt subroutine, we already did this. We already did this one. We already did this one in chapter. In lab 10, and you are gonna do it tomorrow as well. So every time I interrupt, every time you press the button. Every time you press the button, so this interrupt subroutine is called automatically. Every time you press the button, this interrupt subroutine is called. So in this interrupt subroutine, as you see here, I'm gonna toggle this pin. And as I told you, this pin should be used for enable or disable the system tick. You got what I'm saying? Keep in mind, as long as this one is enabled, you are gonna count. So if this one is disabled, if you disable the system tick, so this subroutine is not going to be called. If you don't call the subroutine, you are not going to update counting, because counting is updated by the subroutine. You got what I'm saying? So counting is updated by the subroutine. So if system tick handler, so if you disable it, disable means you are not going to call it. Okay. If it is not called, so you are not going to update counting. So counting would be the same. So for example, if it is 0, 7, so it's going to continue 0, 7 this way because they are not updated, because this is the one that is updating it. Okay. Always keep in mind, if, for example, if any subroutine, for example, if any interrupt subroutine like system, this one, if this one is doing a task, as long as it is enabled, so you are doing this task. If you want to stop this task, just disable it. And that's exactly what you are going to do tomorrow, right? So tomorrow you are going to use the system tick for monitoring, to monitor the measurement. Is that right? Okay. So if you disable it, so no monitoring, you are not going to monitor. You got what I'm saying? It's the same thing here. So here the system tick is increasing the count every 1 second. So if you disable it, so actually you are not going to increase the count. That's exactly what I did. So what I did here, guys, every time I press this one, you can see here, you are gonna, if counting is enabled, if counting is enabled, you are gonna disable it. If it is disabled, you are gonna enable it again. So to resume counting. Is that okay? Just give me 1 second. I'm gonna choose a video right now. Also, I'm gonna show something interesting I told you about before. Look here, guys. I'm gonna show. I told you before, please don't forget this one. You remember this one? I told you this is very critical. Don't forget this one. This is when you this flag bit, this bit or building bit, whatever you want to call it, flag bit. So I told you, if there is one bit, if the interrupt wanna request interrupt, if one interrupt source wanna request interrupt, has to put 1 here, and it's your responsibility to clear it, to put 0 here. Okay. You have to do this one in all interrupts except the system tick, because this is done automatically. Anyway, forget it. So here you have to write 0 here. If you forget this instruction, you are gonna have continuous interrupts. You got what I'm saying? I'm gonna show now in the video. I'm gonna forget it so I'm gonna remove it in the video, and you see what's gonna happen. Okay. But let's imagine before I choose the way. Let's imagine what's gonna happen. What's gonna happen is that, look here, guys. This is how the system should work. Now I have main. Also, I have one subroutine from system tech. I have another subroutine from IRQ, okay, from interrupt, whatever you want to call it, IRQ or external, whatever. Okay, guys. So what's going to happen here? Every 1 second, I'm going to go and come back. Every 1 second. Is that okay? Every time you press, for sure, if this is enabled, if it is enabled, you are going to go and come back. If it is disabled, for sure, you're not going to serve as an interrupt if it is disabled. I'm assuming if it is enabled. Also, every time you press, I'm going to go here and come back here. Is that okay? However, just let's imagine what's going to happen before I choose a video. What's going to happen if you forget this one? Okay. So what's going to happen once I come here? It's going to be continuously here. So all the time, come here, come here, come here. So that means this task is not going to work. Also, this task is not going to work. So that means no time multiplexing, because all the time I'm just here. So come here, come here, come here. So I'm going to have continuous interrupts, because once this bit is one, the program will think this is a new interrupt. It's like one interrupt source continuously requesting interrupt because you forget this one. You get what I'm saying? So what you should see in the video right now, this task is not going to be run time multiplexing. Also, increment is account also is not going to be working, because all the time we're going to be here. I'm going to choose a video and then I'm going to take the question there. Okay. One more thing before I choose a video, very important. One student sent me an email, right? Very important, guys. Okay. What he did, okay, and this is very serious, because this means you don't understand what interrupts are. Very serious. Okay. Look here, guys. So here inside the subroutine, he wrote a code here inside the subroutine to check if you press the button or not. Very serious. Why it is very serious? Because if you don't press the button, I'm not going to come here. You don't need to check. This is what the hardware did for you. You understand what I'm saying? So you don't need to check. You understand what I'm saying, guys? So what he wrote a code to see if you are pressing the button or not. You don't need to check, guys. If you check, you don't understand what is interrupts. Okay? Because that's what the hardware did for me. I don't need to just check by myself. You understand what I'm saying? So anyway, so same thing for the timer here. I didn't need to count for 1 second. Okay, this is the hardware will do that for you. The hardware is gonna count for 1 second and then trigger interrupt. So once interrupt is triggered, it's already 1 second has passed. You don't need to check. You don't know. This is the main idea of interrupt. The hardware will do some work for me. I don't need, as a processor, I don't need to do everything by myself. You understand what I'm saying? So I don't need to check if you press the button or not, because if you didn't press the button, I would not come here. Is that clear? Anyway, so I'm gonna choose now the video, and yeah, I think it's yeah. Yeah, I'm sorry. So this video it's the same thing. It's the same thing, but it's not for counting. It's for flashing. But it's the same thing. Okay. So the system tech is doing flashing. Is that okay? And then every time I press, it's gonna stop flashing. If I press again, it's gonna flash again. Okay. And now intentionally, I'm not gonna clear it, and you will see no flashing anymore, because all the time, so it's the same idea. Okay. So yeah, once I did interrupt, okay, so it's not working anymore. So once I did interrupt, no flashing anymore. Okay, because all the time it's gonna come here. Okay, originally what was supposed to happen, okay, what was supposed to happen, guys, is that there is a flashing every time I press. So it showed flashing on and off, but because I forget to clear this bit. So what's gonna happen is that continuous. So once continuous interrupts to the IRQ. Anyway, so I want you to make mistakes, because you can learn from mistakes. So I want you, when you go home, you can run the same program here, and you can just remove this one and see what's going to happen. Okay, yes, the question's there.
But I have another one. Is the speed control, does that turn off, like, does that stop the system handler from executing? Or
sorry, say your question again. The system tech?
the system control, like,
Yeah, this one.
yeah, does that stop the system handler from executing, or?
Yes, because yeah. So here, this is a register. Okay. Yeah, look here. This is a register. This is a register CTRL. Okay. And this register, there is one bit. Okay. Bit number one. Sorry, the first bit here. Okay. This bit. This bit is used to enable or disable the interrupts of the system tech. Okay. Originally, in the initialization, I'm gonna put one here to enable interrupts. You got what I'm saying? So what's gonna happen here? I'm gonna flip this bit. So if it is enabled, if it is one enabled, I'm gonna make it 0 to be disabled. If it is disabled, I'm gonna make it enabled. So I'm gonna flip it. You got what I'm saying? It's just one bit to enable or disable interrupts of the system tech. You got it? Because what I wanna use the switch for on and off. So here counting. So here the segment are counting, and I wanna do that. I wanna use the switch. If you wanna stop counting, resume counting. Stop counting, resume counting. It's the same thing you are gonna do tomorrow. Okay, so you are gonna use a switch or push button in order to enable the system, disable the system. Okay, in order, you got what I'm saying? If you want to disable the system, you have to make sure, number one, you have to disable system tick, because system tick is doing something. Okay, so what's gonna happen tomorrow, guys, is that here in the main, you are doing a task in the main. Okay, you are doing another task in system tick. Is that okay? And now I want to use this push button on off for the system. If the system is on and I press the button, you turn the system off. If the system is off, I press the button, I'm gonna turn the system on. Is that okay? How can you do that? Very simple. What's gonna happen if I wanna turn the system off? So I have to make sure the interrupts here are disabled so that this task is not gonna run. Is that okay? This is number one. Number two. Okay, so how I can disable this interrupt? Sorry, how can you stop this task in the main? How can you do it? This is a different story, because I can stop this task by simply disabling interrupts. If you disable interrupts, that means I'm not gonna go there. So I'm not gonna execute the subroutines. That means you stop the task. Is that okay? So this is the story here is different from the story here. Here, in order to disable this task, I have to check. So if you have a while loop, so every time you have to check a variable to see if the system should be on or off. You know what I'm saying? That's why in tomorrow's test, here inside this one, you have to do two things. Number one, you have to do something like that to disable this task. Is that okay? Number two, there should be some variable here. You have to use a variable. You can call it on, off, whatever. So this variable should take one of two values. We did it many times in this course, okay? So one value for on, one value for off. And then if the system is on, I'm gonna make it off. If it's off, I'm gonna make it on, okay? And then I'm gonna check here. So here, in order to stop this task, okay, because my system has two tasks, one task here and one task here. If you want to stop the system, I have to make sure this task is off, this task is not working. This task is straightforward. You just can disable interrupts, but here you have to check a variable. That's why here on top of this one, you should here update a variable. Okay, so you should have a variable. This variable should tell if the system is on and off. So if the system is on, you press the button, I'm gonna make it off. If it is off, you press the button, I'm gonna make it on. And then I'm gonna, what I mean by make it, I mean the value. So this one should take one of two values. For example, if 0 if on and 1 is off, or whatever, or the opposite. So if it is 0, I'm going to make it 1. If it is 1, I'm going to make it 0, and then I have to check here. You get what I'm saying? Any questions? So I have a variable, which is a memory location. Memory location. This variable is going to be updated. It's going to be updated by this one. Okay, and then the main function, the main is going to check this one to see if the system should be on or off. Any question? Is that confusing? Any other questions? Are you okay? Any question, guys? Okay. So now the last program I want to teach here, it's exactly the same program I did right now, but I'm going to make a small difference. The small difference that counting, who's going to count? Who's going to count? What I did here, I put this code counting. I did the counting here. Look here. I put the counting here in the system tick so that this one is interrupted every 1 second, so that I want to count everyone. I'm going to increment it every 1 second. Is that okay? Now I want to make it different. Okay, so what I want to do is that I'm going to move this one from here. I'm going to put it here. So that every time there is on this pin, you remember in this one here, you have external pin. Every time there is a falling edge, you are going to increment the count. Okay, guys? Increment the count every time there is a falling edge. Because it's connected to the switch. So every time I press the switch, I'm gonna call this subroutine, and then I'm gonna move this one from here to here. Okay. Again, this program is very useful because you can use it. For example, guys, for example, you have here like sensor, this pin. So here in this example, every time I push the button, okay, I'm gonna trigger interrupt. In reality, this can come. You have some kind of sensor. You want to count how many times something happened. You want to count how many times something happened. So here you have a sensor. For example, you have a sensor here. This sensor is gonna transmit some light this way, and I can put it like in a street so that every time a car cut this line, so this one is gonna generate a pulse this way, and then I'm gonna apply the pulse here. Okay, or you can, for example, you can put it at the entrance of a store, so that every time someone enters the store, you are gonna cut the line. Once you cut the line, you are gonna generate a pulse like this one. So what I want to say, there are many applications. Okay, in this application, I have pulses, and I want to count how many pulses we have, how many pulses we got. We can use this program. You get what I'm saying? Because this, I'm gonna connect these pulses to I'm gonna put it here, so that every time there is a pulse, you are gonna trigger interrupt. In the interrupt here, I'm gonna increment the count. Is that okay? So I'm gonna show how it's exactly the same program, but I just move the code. It's exactly the same thing here. Look here, guys. All what I did, I just move this code. Just to move code from here to here, because I want to increment the count every time there is external interrupt. Okay. Still, we need time multiplexing. So I'm gonna, for time multiplexing now, you have the option. You can put the time multiplexing in the main program this way, or you can put it here inside the system tick if you want. So you have the option. Okay. So, and that's exactly what I did. So what I did here, guys, as you see here, inside the interrupt subroutine, as you see here, so I put count here. I increment the count here. So I increment the count. Okay. For time multiplexing, you have the option. You can keep it in the main, as I did here. So you can actually use the same code this way, or you can put it in the system tick here. I put it in the system tick here. Okay, guys. Again, sometimes in some application, I want to count how many pulses we have. Okay. If this is the case, you can just apply. You can put it here in the IRQ. Okay. Sorry, in the this to trigger interrupts here, and then every interrupt you increment the count, and you display count. There is another application I'm going to explain it right now for something similar to this one. I want to explain it in chapter 5. But also, because it's related to what I said right now, it's already here. So I'm gonna also explain it. One way, if I want to measure the motor speed, okay. So one way to do that, I can attach a disk. As you see here, we have a disk here. This is the motor. We have a motor this way. So I can attach a disk to the motor, and then this motor is gonna go through a package like this one. This package has something like that. It has an LED to transmit light, and it has what's called phototransistor. So it's phototransistor. So here, this one here is in one side here, and this one is in the other side here. And the disk is gonna go through between them here. Okay, what is the idea? What is the catch here? Okay, very simple. The idea is, you understand what I'm saying? So here, actually, the disk has to be here. Okay, it's gonna rotate, spin here between these two. The idea is that, look here, guys, if we have a disk, the disk has 2 holes. Okay, you can put more holes if you want, but here let's assume we have 2 holes. It can be more, but anyway. So the idea is that when there is a hole here, when the hole comes here, so actually the light is gonna go through the hole. It's gonna hit the piece, and this phototransistor. This is how this phototransistor works. Once the light hits the base, so actually the transistor is on. So you are gonna make it short circuit. Okay, it's on because when the light hits the base, it turns it on. So so the output here voltage is gonna be high, 5 volt. You got what I'm saying? So every time the hole comes here, the light is gonna go through it. The transistor is gonna be on, and the output here is gonna be 5 volt. Okay, this is one case. The other case, if this part here, the solid disk come here, okay, so there is no light. The light is not gonna hit the base. So this one is gonna be open circuit, and the output is gonna be 0. So actually, if you look at what kind of signal I'm gonna get here, I'm gonna get a signal something like that. Okay, so here the hole, we have a hole here, hole here. So for every one rotation, if one complete rotation, we should have 2 pulses this way, 2 pulses for 1 rotation. You got what I'm saying? So for sure, if I add, we can add more holes for sure. For example, if we have 4 holes, that means we should have 4 pulses every 1 rotation. Okay, again, I'm gonna say again the electronics. You can buy this package. Okay, just one package this way. I'm gonna say the electronics behind it. The electronics behind it is, as you see here, if when the light hits the transistor, it's gonna make it short circuit, and if it's a short circuit, the output here is gonna be 5 volt. Okay. If there is no light, because there is a disk here on the disk, or the solid part of the disk, when it comes here, there is no light. So the transistor should be open circuit. When it's open circuit, this one is going to be 0 volt here, 0 volt. You got what I'm saying? So now, okay, so now I want to measure the motor speed. How can we measure the motor speed? And how this one is related to what I explained right now? I want to count how many pulses we have. It is related. How it is related? Very simple. So if I connect these ones to the previous program, I have taught right now. So I'm going to connect this one to interrupt IRQ, or it's the same thing when you say external interrupt. So I'm going to connect this one to the pin, and then you are going to count. You are going to count how. So for example, for every rising edge, you are going to increment the count. Okay. So if you count how many pulses we have in 1 second, and you divide this number by 2, what is this? This is how many rotation or revolutions per second. This is the speed. You got what I'm saying? So what you can do is, listen to me. What you can do is that we have external interrupt. It's connected to this one. Okay. Every time you want to measure, what I'm going to do is that I'm going to enable external interrupt. Okay. Also, but I have to keep it enabled for 1 second. Okay. I need to keep it enabled for 1 second, because I want to count how many pulses we have in 1 second. And then I'm going to divide it by 2, right? After 1 second, I'm going to turn it off. For sure, if you want to enable it for 1 second, you can do it in the main program, or you can do it in by system tech. So I can enable external interrupt. I can count for 1 second using delay. This is if you do it in the main program using delay. After 1 second, I'm going to disable the interrupts of XTI, okay? Because I'm going to stop counting, okay? So for 1 second, so I'm going to enable it for 1 second to count how many pulses we have, okay? After 1 second, I'm going to disable it. After you disable it, now I can divide this number by 2. How many number by 2? Okay, guys, any questions? Okay, in this chapter, I'm going to explain, we can do it in a different way, okay? And that's what I'm going to explain in this chapter. We can do it in a different way. If there is a way, listen to me. So now, if I want to measure the motor speed, I can do it in one of 2 ways. One way I already explained, I need to count how many pulses we have in 1 second. This is one way, right? And if you want to do this one, you have to use external interrupt. Okay, because actually we can have interrupt here, interrupt here. So every time there is interrupt, I'm going to increment the counter. So here increment the counter, increment the counter, so I'm going to see how many counts we have in 1 second. Is that okay? There is another idea. That's what I'm going to explain in this chapter. Okay, if I have some way, to measure the time from here to here. So if I can measure the time from here to here, from this pulse to this pulse, okay, or from this pulse, yeah. If I can measure the time from here to here, and then I can, this is 1 over this time is going to give you the frequency or how many rotations you have per second, and you can multiply by 2 or whatever. You got what I'm saying? Because actually what happens here, yeah, you need to multiply by 2, because what happens in this case, here from here to here, let me draw it. So from here to here, from here to here, from here to here. Okay, so it's actually from here to here is going to be 1. I think this is half. Okay, this is only half rotation, right? So yeah, so if I can get this time, okay, and then you can multiply, if you multiply this time by 2. So anyway, so if you have the time here, assuming for sure, you can't just measure this time. So anyway, if I have some mechanism, and that's what I'm going to explain in this chapter, by the way. Yes, we have some tool, very interesting tool to measure time. Okay, so instead of counting how many pulses we have, there is something I'm going to teach in this chapter. It's called input IC, input capture. Input capture. So input capture is actually a mechanism or a technique we can use to measure time. If I can measure time from here to here, okay, and that's what I'm going to explain in this chapter. Just you can measure. If I can measure the time, I can for sure I can get the motor speed. Okay. Anyway, so I'm going to explain this one in this chapter. So let me go back. Okay, any question here, guys, for this one? I think that's very easy, right? So anyway, I think this is the end of this chapter. In chapter 3, I think there are 2 quick topics I'm going to explain. Any questions so far? Okay, so let me go back to finish chapter 3. Just we have 2 topics here in chapter 3. Yeah, I think I already explained everything except, yeah, 2 quick topics. I think I explained all of that, yes. Yeah. So only 2 quick topics here I'm going to explain to you. So one topic here about there is one device, but here there is something we call it RGB LED. RGB LED. So R here means red, green, blue. LED. So it's only one LED, as you see here. One LED. Okay. So one device, one package this way. But different from the LED we have, so this LED can only light only one color. Is that okay? No, this is only one LED, but this one can give you can light red or green or blue. You get what I'm saying? So it's only one package. This one can turn red or green or blue. You got what I'm saying? So I'm gonna explain quickly. Number 1, how I can use something like that in application. Number 2, how I can program it. Okay, quickly. Number 1, how something like that is going to be useful in application. Yeah, for sure, it's going to be useful if you want to convey a message to the operator of the system. I want to tell the operator of the system, if the light is red, it means something. If the light is blue, it means something. If it is green, it means something else. So I want to just using colors, I want to convey a message to the operator of the system just by looking at the color. Is that okay? For example, here I give you one example, but you can think about many other examples. For example, in tomorrow's in tomorrow's in tomorrow's test, here, for example, if you have a tank like similar to what we did tomorrow, and if the height of the liquid below a certain level this way, I can turn the red on. If it is above a certain level or the opposite, so I can make this one blue, I can make this one red, If it is in between, I'm gonna make it green. You got what I'm saying? But so you can use this one to do something like that, so that visually, when you look at the color, you can know what is the status of the system. Is that okay? I'm gonna tell you something similar to the here. If you go to the second floor in the brown hole, there is a fountain, okay? Water fountain. So in the water fountain, you can see three LEDs. These are normal LEDs. They are not RGB, okay? So one of them is gonna tell you the filter, the status of the filter, okay? So do you need to change filter? So one of them, yeah, it's gonna be the filter is okay. This one, I think it is one of them, I think it is red to tell you have to change the filter. Okay, so if you want to create a system like this one, instead of using 3 different LEDs to convey a message to the operator or to the user of the system, you can only use one. You understand what I'm saying? So here, yeah. So here you can use only one, and you can tell if this one is green, that means the filter is okay. If it is, for example, blue, that means you are close, you should be ready, you are close to change it. Once it is red, that means you have to anyway, so you can think about too many applications, but it's only one device that can give 3 colors. You can think, and every color you should convey some message, okay? So now how I can use it, okay? If you, is it difficult to use it? No, it's very easy, similar to what we did in this course in many places. First of all, if you buy it, we have 2 types of them. One of them is called common anode, and the other one is common cathode, okay? Here, I represent it like three, but actually it's only one device. You are gonna see it like one device, but this is like, it is if it is 3, but it's not 3, it's only one device, okay? So, for example, if you buy one of them and it is common anode, so the way you have to do it is, so when you buy it, so this one actually, this package, it has four pins. So that means this is the common part. So this pin has to be connected to 5 volt, okay? And then now you have 3 pins this way, okay? You can connect the 3 pins to these 3 pins, you can connect them to the microcontroller this way, so that if I want to turn the red on, so I'm going to put here 0, 1, 1. So if you put 0, 1, 1, so here you are going to put 0 volt, here you are going to put 5 volt, 5 volt. So on, so this one is on. If you want to turn the green on, so I'm going to put here 0 volt, 5 volt, 5 volt, okay? If you want to turn the blue on, so here I'm going to put, so anyway, whatever you want to turn on, you should put 0 volt, okay? The other one, you have to put 5 volt. For sure, I want to tell you, and you should know that if you connect the LED directly to the microcontroller this way, you are going to burn it out. You are going to burn it out, okay? You should know from electronics that we need to connect the resistor here to limit the current. So you need to do something like that. You need to put some kind of a resistance to limit the current. Anyway, okay, guys. So very easy. So the other one, if it is common anode, so as you see here, so actually you have so here the common part is the anode. So I'm going to connect this one to 0 volt, and then whatever the one I want to turn on, so I'm going to actually put 5 volt here. Again, in this diagram, I'm showing you three of them, but actually it's going to look like only one LED. Okay, guys, any questions? Pretty easy, right? So at the end, you just one LED that can give one of 3 colors. Every color you want to convey a message to the user or the operator of the system, and the way you are going to do it, just three pins, okay? And then based on if it is on or off, if it is common anode or common cathode, so sometimes 0 is going to turn on, sometimes 1 is going to turn on. You got what I'm saying? So anyway, so actually, yeah, if you want to turn 1 on, for example, I'm going to put here 0, 1, 1. So red is on. If I put here 0 this way, okay, you can find this one online. You can buy it. Any questions? Okay. So last thing I want to teach here, guys, is about. I think I'm sorry. I think I made a mistake here. This one is we call it RGB LED. This one is okay. I think I made a mistake here. This one is relay. It's something else. I'm sorry for that. So just correct it. So there is something else, we call it a relay. I want you to understand what is the story of a relay. Also, there is something else very important. Also, I want you to understand. Look here, guys. Usually we have this problem. I'm quite sure you are going to have this problem when everywhere in your capstone, in any, when you do application by yourself. Look here, what is the problem? I'm going to tell you what is the problem. Very important. Look here, guys. If I have a microcontroller here, microcontroller, I have external pin here, okay? And then I want to connect here a device, like for example, a small motor or whatever, or I want to connect a coil this way, whatever, okay? Usually we have this problem, usually, okay? And I'm gonna tell you how we fix it. The problem is that usually microcontroller has a maximum current it can provide. You got what I'm saying? So the problem is that if I can get from here, just for example, you need to check the data sheet, but just an example, if this one can give you, for example, up to 20 milliampere, and I have a motor here, this motor, for example, needs 100 or 200 milliampere. Okay, guys. So what can I do? You understand what I'm saying? So I can't connect it directly because a microcontroller cannot give me enough current to support. Sometimes it does. It depends on how much current you need, right? It depends on, for example, if you want to connect LED, I think it should be okay for an LED, but for something like a motor, I don't think it can support a motor, okay? Because a motor, it needs too much current. Is that okay? So how can we solve this problem? Very simple. So what happens, guys? There is something. It has different names. One of the names is buffer. So a buffer or something like that. So actually, you need to connect a circuit here, a special circuit here. This circuit is going to take 200. It's going to take 20 milliampere from here. It's going to provide this one 200 milliampere. So it's actually a chip. You can buy this chip. Okay, I'm quite sure you will need it because usually microcontroller does not provide enough current. You got what I'm saying? So the very simple way of this one here is actually a transistor. So this buffer can be just a very simple transistor. I'm going to tell you how. So for example, here, what can we do is that, so I can, a very simple way, what can we do here? I can connect here. So the circuit here, I told you we need to connect a circuit. This circuit can be like a transistor this way. Okay. And then I'm going to connect the motor here. And then this one is connected to VCC this way. Okay. Look at the idea. Very simple idea. So the idea is that usually the gate current, if you use bipolar transistor, usually, or if you can use MOSFET, or usually the base current or the gate current, usually this current is very small. You know that, right? Very small. But this current can be very high current. Okay, and this current is coming from VCC. It's a different source. It's not coming from the microcontroller. That's why we are gonna withdraw very small current from the microcontroller, and then we are gonna provide too much current to the motor here. You understand what I'm saying? So you are gonna have this problem for sure in your capstone or something like that. Again, the problem is microcontroller. Usually, when you want to interface a device that needs too much current, microcontroller is not able to give you this current. You have to put a circuit in the middle. This circuit, it has several names. You can buy it online. It can be just, you can buy IC. This IC can have multiple transistors like this, or you can buy a single transistor. Okay. So again, the idea is that here, this one can take a small current from here and can provide a large current here. Okay, because this current is actually coming. This current is coming from a different source this way. Okay, and as you know, here, if you have 5 volt here, you can turn the transistor on. This is how it works. Okay, so if I turn the transistor on, I'm gonna make it short circuit. Once I make it short circuit, this current, I'm gonna turn the motor on. For sure, if you put here 0 volt, so I'm gonna turn it off, so the motor is not gonna work. Okay, guys. So that's exactly what you can do here. For example, you can put a motor this way here, and then you can put the transistor this way, and then you can connect it to the microcontroller. By the way, every time there is some kind of a coil this way, this coil can become from a motor or latch. You know what I mean by latch? Okay, when you open a door like this one and you enter password and open the door, you hear something tick. You got what I'm saying? So actually what happens, there is something like a latch. So latch, the idea of the latch, you have a coil this way, and actually you have a bar, bar this way. This bar can close the door. For example, you can close the door. Once you energize the motor, so you are gonna turn the coil into a magnet, and the magnet maybe is gonna pull this one out to open the door. You know what I'm saying? It's called a latch. So you can search it online, but this is the main idea. The main idea is that it has a coil and it has a bar like this one. Okay. So what's gonna happen once you energize the motor? You are gonna pull the bar. Okay. So you can use it if you want to open a door, for example. So the bar is gonna close the door. If you want to, once you energize the motor, you are gonna pull the bar to open the door. Something else. We call it a latch. So at the end, you just have a motor this way. Okay. So every time you have a coil like this one. This coil can be a motor or latch or whatever. Every time you have a coil, you need to connect a diode this way. Okay. Why? For protection. Very important thing, for protection. Okay. Why it is for protection? I'm going to tell you why. So this one is used for protection. Actually, what's going to happen is that if the transistor is on, the current is going to go this way. You know from electronics, the current cannot go this way, right? Because the diode is one way. You get what I'm saying? So the current is going to go this way. Okay. The problem can happen when you turn the transistor off. When you turn the transistor off, there is a storage. Coil is going to store some energy. And when you store energy, so if you go this way, actually, so what's going to happen? This is going to be a positive, this a negative. So it's going to be like a battery storing some energy. So if you don't put a diode this way, so this one may discharge in the transistor and it's going to damage it. Okay. So what happens usually, we put like a protection. For protection, we put a diode this way so that this one can discharge here, okay, in the diode instead of the transistor to protect it. You got anyway. So maybe just in case you are gonna read, I'm sure you are gonna read something like that in the future somewhere. Okay. But again, what I want to say, guys, here the conclusion is that when you do interfacing of a device to the microcontroller, you are gonna face a problem. The problem is microcontroller is gonna provide you certain amount of current. If you need more current, so you have to connect external circuit this way. This circuit can be a simple transistor, or it can be a IC, a chip. This IC actually has inside it, you maybe have multiple transistors this way. Okay. And also, if you have a motor or a latch, okay, so actually there may be you may need to connect a diode this way so that it's a for protection. Anyway, you can find online things like that. Okay, guys. Any questions? Okay. Now, okay. So what I told you currently, guys. I told you about if you need. If I want to connect a motor, for example, a DC motor this way to the microcontroller, and microcontroller cannot give you enough current, so you have to connect a circuit here. This circuit sometimes is called a buffer. It has several names, but one of the names is just buffer. Okay. Okay, this looks okay, looks nice. However, it's not going to work all the time. It's not going to work with me all the time. For example, why it's not going to work all the time? This one is going to work if you have DC motor, for example. What if I want to control? So I have a microcontroller, this one, and I want to control AC motor, for example. I have AC motor. Okay, for sure, microcontroller can only give you DC current, DC voltage. Okay, but it cannot give you AC motor. I'm going to tell you. So in this case, we use another device. We call it a relay. It's a very interesting device. Okay, so how it works? What is the idea of the relay? I'm going to tell you what is the idea. Okay, so this is we have for sure two types of the relays. We have mechanical relays like this one. This is a mechanical relay. Also, it's very important. I'm sure you are going to use something like that in the future. Okay. The other one, we have solid state relays. So we have two types of relays, mechanical and solid. Let's talk about the mechanical now. So if you buy this relay this way, so the relay, it has something like that, as you see here, guys. It has a coil, as you see here, coil. Also, it has switches, as you see here, switches this way, okay? So if you buy it, it's gonna be like a package. This is one package. This package has two inputs this way, and it has the switches this way. How it works, I'm gonna tell you how it works. Look here, guys. As you see here, this is a common part. So if you look at these two parts, we call them normally closed, But if you look at these two, we call them normally open. So we have here these two are normally closed. These two are normally open. Okay? What do you mean by normally? I mean, okay, let me complete and you will understand what I want to say. Okay, guys. So that means if you don't energize the coil, if the coil is not, if you connect it or there is no current in the coil, it's going to be this one here closed and this one here open. That's why it's called normally. So the word normally here is if the coil is not energized, if there is no current here. However, if you energize the coil, if you connect supply here and you energize the coil is gonna become a magnet. Okay, you know when you have a coil and you energize the coil becomes a magnet. Because it's a magnet, actually it's gonna pull this one, is gonna bring it here. So this one is not gonna be connected this way or here anyway. Okay, so gonna pull it here. So here now, this one is normally closed. So normally closed, it means these two pin zero connectors here. If the coil is not energized, they are going to be closed. If you energize it, you are going to open it. Okay, and this one here is normally open, but when you energize, you are going to be closed. You got what I'm saying? Okay, what's interesting here? What is interesting is that, as you see here, guys, it's like, again, it's like a switch. You open or close. Switch. However, so here, this switch is closed, but I can open it. Very simple. I can open it. Okay. We have another switch here. This switch normally open, but I can close it. How can you close it? Very simple. All what you have to do, you have to energize this one. This one becomes a magnet and it's gonna pull it. So that's why when you use this relay, you will hear some tick, 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 because contactors are gonna connect here. Okay, so okay, this is what's called the relay. Yes, that's what's called the relay. Okay, how this is interesting. Okay, you can use a relay to control a circuit with 100 voltage, as you see here. I'm going to tell you how using the microcontroller. So again, this is the problem we are trying to solve. I have a microcontroller. I have like a motor, and this motor 110 voltage. Okay, and I want the microcontroller to control it. Okay, connect, disconnect, connect, disconnect. Okay, for sure, I cannot connect directly this way. This is very naive because microcontroller cannot give 110 voltage AC to the motor. Okay, cannot do that. That's why this is what we are going to do as here. Okay, look how I made it. Look here, guys. This is the relay. This is the relay. Okay, and then we have here a lamp or motor or whatever. It's connected to 120 volts this way. Okay, and this is a microcontroller is here. Microcontroller can turn the lamp on and off. Okay, how it works? As you see here, guys, originally the lamp is off. So here, if I output 0 volt here, okay, let me tell you the whole story. If I output 0 volt here, okay, so the transistor is off. Because the transistor is off, so the coil is not energized. So there is no current here. Because there is no current, so every switch is normal. So this is like a switch and another switch here. In this case, I'm going to use normally open. So here, because this one is not energized, so every switch is normal. So here, this one is open. okay, because you didn't close the circuit, you didn't, so that means the lamp is off, okay? If I want to turn the lamp on, the microcontroller has to output 5 volt here. When you output 5 volt here, you actually connect the transistor. So here, and then the current is going to flow this way. And then now the coil is energized, and now the switch is going to come here in order to close the circuit this way to turn the light on. Any questions? By this way, the microcontroller can control like AC load, turn it on, turn it off this way. Okay, guys? Again, the way I designed this circuit here, okay, this is important to understand. Listen to me. Because I used the normally open, again, it's like you have two switches here. This one is normally open. In this case, I used the normally open. So that means the lamp is going to be normally the lamp is off. If you want to turn it on, you have to put 5 voltage to turn it on, okay? But if I connect the lamp, instead of connecting it here, I'm going to use this switch here. So here, I'm going to connect it here. So that means the lamp is on all the time. And once you want to turn it off, so you need to energize the motor. So which one I have to use? Again, it depends on your application. Sometimes I use this one, sometimes I use this one. It depends on what you want to do. You want to turn it on all the time, and then I want to turn it off only for a certain time, or it should be off all the time, and then I'm going to turn it on for some time. So you have, it depends on the application. So both of them are okay. So you have two switches, as you see here, guys. One switch is open all the time, normally open. We call it normally open. And then once you put here, once the transistor energize the motor here, you are going to close it. Or the other case, it's closed. It's all the time it is closed. Okay, and then you can. Anyway, I don't want to spend too more time. That's just here. It's more electronics. But anyway, regarding how can you connect it to the microcontrollers, it's very trivial, very easy. So all what you have to do if you want to use something like that is you just, it's one pin. And okay, just one pin to the microcontroller. Okay, just one pin to energize the motor. And so all what you have to do, you need to configure this pin output, right? And then you can write 0 volt or you can write 5 volt. Already we have done this one. So programming wise, it should be very easy, very trivial. Okay. Also, I give you here a video, YouTube video. You can watch this one. I don't think it's just very easy video. Oops, it's already fixed. Okay. So I'm not gonna spend. You can just watch this video. It's about relays. Relays are important for sure. Again, regarding the connection, it's just very easy connection. It's just one pin from the microcontroller. This pin you can put 0 volt or 5 volt. Okay, guys. Anyway, thank you. So next time I'm gonna start chapter 5. Okay. Any questions?